Okay, this is going to be a new topic in your notebook. Go ahead and take a minute. This is what it's going to look like at the end of the video. Okay, you're going to go ahead and get three problems done. So at some point, I need you to go ahead and pause the video, copy everything down. I'm going to assume you already did that, and we're just going to go ahead and get started. So this is applications of systems of equations. There's going to be four different steps to applications. Basically, we're still working with systems of equations, which means you can still graph your answer. You can solve it by substitution or elimination. Where this changes a little bit, though, is now we're using word problems to attack these questions, right? So because it's a word problem, they don't give you the system. You have to come up with the system yourself. In order for us to do this, step number one, obviously you're going to read the question. But once you're done reading the question, you're going to go ahead and define your variables. I'll show you what that looks like. We've done that before, but it's been a while. Step two, you're going to write your system equations. Honestly, that's probably going to be the hardest step, is for you to come up with your own equations for the word problem. Then you're going to solve the system, usually by substitution or elimination. And then step number four, finally, we need to answer the question. Okay. So let's take a look at number one. We're going to show you a different types of problems. The first one we're going to call a simple problem, even though it's really not. Okay, but they're literally like you just translating what they say. So let's look at the first one. It says Austin and Maddie went to swim practice. Maddie swam more than twice as many yards as Austin. Together, they swam 65 yards. How many yards did Austin swim? So, what is it that they're asking me? They're asking me how many yards did Austin swim. So that's obviously something that I don't know. I need to come up with variables first. So step one, we're going to define your variables. I'm trying to find out how many yards Austin swam. I don't know how many that is. So I'm going to go ahead and start writing my let statements. And I'm going to say something like let A represent the number of yards Austin swam. So now I know, okay, I'm going to be using the variable A and it's going to stand for how many yards Austin swam. That's not enough though, because with these kind of equations, we've been dealing with two different variables. So if I'm going to let A represent the number of yards Austin swam, what do you think is a good other variable that I don't know just yet? Well, that would be the number of yards that Maddie swam. So I'm going to go ahead and define another variable. And I'm going to say let M represent the number of yards Maddie swam. So step number one is done. We were able to define our variables. I'm using the letter A and I'm using the letter M. Step number two, and I said this is going to be the hardest one, is going to be write your system of equations. So I need to come up with two different equations, okay, according to the word problem. So let me just go ahead and go back into the word problem. It says Austin and Maddie went to swim practice. That's really not going to give me an equation, so I'm just going to kind of skip that one for now. The next sentence says Maddie swam two more than twice as many yards as Austin. So that's definitely going to give me an equation. I just need to know how to translate it. So let me go ahead and highlight this one. Maddie swam two more than twice as many yards as Austin. So on these kinds of statements, did they tell you something about Maddie or did they tell you something about Austin? Here, they're telling you that Maddie swam, right? So they're telling you something about Maddie. And they're telling you that that distance that she swam is equal to two more than twice as many yards as Austin. So I'm going to come up with a formula. I know that they're saying Maddie swam. So that's saying like Maddie equals. So I'm going to go ahead and write M equals. That's telling me that Maddie swam, right? How much did she swim? Well, she swam two more than twice as many yards as Austin. So there's a couple of things going on. I know that if I'm going to have two more of something, that means I'm adding two. But please, please, please do not start with the two plus. I know that's the way you want to write it. But with these types of problems, you're going to have to kind of write it backwards for that particular statement. So let me just ignore the two more for right now. And let me focus on twice as many yards as Austin. Twice as many. So if I had $10 and I have twice as much now, that means I'm multiplying it by two. So I'm taking the number of yards that Austin swam. I don't know how many yards he swam, but I know that it's twice as much. So I need to take Austin's value and multiply that by two. Remember, A represents the number of yards that Austin swam. So really, if I write 2A like this, That represents twice as many as yards as Austin, because we take Austin's yards and multiply it by 2. So this right here represents twice as many yards as Austin. Now, that's great, but I need to go 2 more than that, right? So if this is twice as many as Austin and I want to go 2 more than that, this is where I add the 2. So again, this is twice as many yards as Austin. This is 2 more than twice as many yards as Austin. And that's how we get that green equation to pop out. So this is a translation of that green sentence is my green equation. This is telling me that Maddie swam 2 more than twice as many yards as Austin. All right, I know that's a little bit confusing, but I promise you the more you see it, the better you get at it. Okay, so you're just going to have to get a little bit of exposure, and then it'll come more naturally as you do more of them. Let's look at the next sentence. It says, together they swam 65 yards. So let me go ahead and use that. That is going to give me a other formula. Let me go ahead and highlight that one in pink. Together they swam 65 yards. Well, if I'm going to put stuff together, like let's say you have $10 and I have $15 and we put them together, that'd be 10 plus 15 is $25. So when I say together, that means we're adding them up. What am I adding up? Well, I'm adding up Austin's yards with Maddie's yards. And I don't know how many Austin has, and I don't know how many Maddie has. And I use the letter A and M, but I know that if I put Austin together with Maddie, then that total is going to be equal to 65 yards. So this is my second equation right here. When you put stuff together in mathematics, you're adding them together, okay? So there's my 2 equations. This was the difficult part of this problem, is coming up with those 2 equations. Now that we have the 2 equations done, I'm done with step 2. I was able to write my system of equations. Step 3 is to solve the system. So you have a decision to make right now. You're either going to use substitution or you're going to use elimination. Well, you use substitution if one of the variables is easy to solve for or it's already completely solved for. And you do use elimination when the variables and equations are completely lined up. Well, it doesn't look like they're lined up, but I do have that letter M by itself. That means I'm going to be using substitution because anywhere I see the letter M, I can replace it with 2a plus 2. Anywhere I see this letter M, I get to replace it with 2a plus 2. So I look at the other equation. Do I see a letter M? I sure do. I'm going to replace that M with 2a plus 2. So let me go ahead and start doing that way over here because I have a lot more space over here. Instead of writing a plus m equals 65, I'm going to write a plus, there's my m. Instead of m, I get to replace it with 2a plus 2 because they're the exact same thing. So plus 2a plus 2 is equal to 65. Now we just need to solve that system, right? I said I'm going to be using substitution. Actually, let me go ahead and put a little thought bubble right here. Substitution is the way to go for this particular problem. So we're going to go ahead and add up those a's. A plus 2a, that's 3a plus 2 is equal to 65. We're going to subtract 2 on each side. I get 3a is equal to 63, and of course we're going to divide by 3. And I get a is equal to 21. I know I went pretty fast through that process because honestly that part should be reviewed, right? What's the new thing is this step right over here. Okay, at this point, I got, what did I just solve for? I found the first part of my answer. Normally I would say, hey, once you have the first part of your answer, get your second part of the answer by taking that A and plugging it back in, right? I can definitely find the second part of my answer, except the question is asking me how many yards did Austin swim? And I know that Austin swam 21 yards. So I don't need the second part of that answer for this problem. I can go ahead and answer the question, but I need to answer the question. So the question was, how many yards did Austin swim? And I get to write Austin swam 21 yards. That's my final answer. We're going to go ahead and box that in. And we are done. All right, let's go ahead and take a look at problem number 2. Problem number 2 is a perimeter problem. They gave you the formula P equals 2L plus 2W. That is super important. So let me go ahead and write over here on the side, just talk about a perimeter. A perimeter means the distance around a particular figure. So I'm going to go ahead and draw a rectangle over here. And on this rectangle, I'm going to draw a little ant. Here's my little ant. Don't make fun of my ant. But there's my little ant, okay? And if this is, I don't know, if this is 5 feet and this is 8, let's go inches. If this is 5 inches and this is 8 inches, the perimeter would be the distance it takes for that ant to go all the way around that box. So if it were to start walking, let's see, it would go this far. Is it done? No, but I know that it traveled 8 inches. And then it would continue walking and it would go this far. Well, this distance would have to be 5 because it has to match up with the left. Is it done going around the box? Nope. Again, we're going around the entire perimeter. Sorry about that. We're going to continue walking that little ant, and now it's going to go this distance, which is another 8 inches. It's not done yet. It's got to go all the way back to where it started, and then it's going to go another 5 inches there. So I'm going to add all those up. 8 plus 5 plus 8 plus 5. That is 26 inches total. More importantly, we just found the perimeter of that box, right? And notice when I did that, I did the length twice. And I did the width twice. So that's where that formula is coming from. For the perimeter of a rectangle, you add up the lengths twice and you add up the width twice. Okay, so we are going to be using this quite a bit for the perimeter of a rectangle. Okay, so now that we know how the formula looks like, let's go ahead and get started into the problem. It says the length of the rectangle is 5 inches less than 4 times the width. The perimeter is 90 inches. What are the dimensions of the rectangle? Again, they're asking me for the dimensions, and the dimensions would be the length and the width, and I don't know those. So on step 1, when they said define the variables, since I'm trying to find the length and the width, then that's what the variables I'm going to be using. So let me go ahead and say let L represent the length. Let W represent the width. Okay, I got step number 1 done, which was to define my variables. Step 2 is the difficult part. That's where you have to come up with your own equations, okay? So let's go back and read the question again. The length of the rectangle is 5 inches less than 4 times the width. That's definitely going to give me a formula. Let me go ahead and highlight that sentence in green. The length of the rectangle is 5 inches less than 4 times the width. So the first thing I'm going to decide is, are they telling me something about the length, or are they telling me something about the width? Here, they're telling me something about the length. I know that it is 5 inches less than 4 times the width. So they said the length is a translation for the word equals. So they're telling you the length equals. Let me go ahead and start with that statement. The length equals. What did they tell me about that length? Well, they told me that it equals 5 inches less than 4 times the width. This is just like that other problem where I know that 5 inches less means that I got to subtract 5, right? Like if you have $13 and your friend has $5 less than that, you take the 13, subtract the 5, okay? So I know that says to subtract 5, but first, your first focus should be 4 times the width. So let me figure out how much 4 times the width is first. How do I write 4 times the width? Well, that would be 4W. There's your 4 times the width. But now I want to go 5 inches less than that. How do I go 5 inches less than 4 times the width? I'm just going to subtract 5 from 4 times the width. So this is telling you that the length is 5 inches less than 4 times the width. All right, hopefully that translation made sense to you. Here is my green formula. The other one is kind of tough. It says that the perimeter is 90 inches. So let me go ahead and highlight that in pink. Please, please, please do not write this next section down because I'm going to make a little bit of a mistake, okay? They're telling me that the perimeter is 90 inches, which means the perimeter is, remember, is means equals 90 inches. Now, don't write that down, okay? That is a true statement. This is saying that the perimeter is 90 inches long. It's not like I'm lying to you. However, I don't want to use this formula because I have the letter L, I have the letter W, and now I have the letter P. Now I got three variables going on, and that is very, very difficult to work with. Okay, I would much rather stick with the L's and W's instead of introducing this new variable P. So then how am I going to use the fact that the perimeter is 90 inches? Well, remember, we have this formula over here that says that the perimeter, the perimeter is the same thing as 2L plus 2W. But guys, I know the perimeter. How much is the perimeter? Well, we just said that the perimeter is 90, so instead of writing the letter P here, I can replace this letter P with the number 90 because I know that the perimeter is the same thing as 90. And I'm going to write down the rest of my equation as well. So let me go ahead and erase this. Instead of saying P equals 90, I'm going to use that formula over there. But instead of writing the letter P for perimeter, I get to write the number 90. So I get to write 90 is equal to 2L plus 2W. This is going to be my pink equation because the P stood for perimeter and I know that the perimeter is 90. Now that I have my two equations, that was the hard part, I have to decide whether I want to use substitution or elimination. Well, the equal signs are lined up. The L's did not line up. The W's didn't line up. No, I don't want to use elimination. Substitution I can use because I already know how much L is. L is 4W minus 5. That means on the other equation, anywhere I see an L right here, I get to replace that L with 4W minus 5. So let me write down this bottom equation, but when I get to this L, I'm going to replace it with 4W minus 5. We're going to go ahead and use substitution again because I already solved for one of the variables. And I get to write 90 is equal to 2. There's my L. Instead of L, I'm going to write parentheses 4W minus 5 plus 2W. All right, something screaming at me for it to do right now, which is distribute that to. I get 90 is equal to 8W minus 10 plus 2W. We're going to go ahead and combine like terms. I get 90 is equal to 10W minus 10. And now I get to solve for W, which means I'm going to add 10 to both sides. I get 100 is equal to 10W. We're going to divide both sides by 10. And I get 10 is equal to W. That's the first half of my answer. Let's see if I answered the question. It said, what are the dimensions of the rectangle? Guys, I don't know the dimensions just yet. I know the first dimension, the width is 10, right? Let me go ahead and find the length. How do I find the length? You take that 10 and plug it back into either equation. I'm going to plug it into the first equation. So the length is equal to 4 times the width. What did we just say the width was? We said the width was 10 minus 5. Guys, all I did is I took this 10 for W and I plugged it in right here, or I substituted it. And what do I get? 4 times 10 is 40 minus 5. That's going to give me 35. So the length is 35. It looks like I got both part of my answers. Now, step 4, I need to answer the questions, which is what are the dimensions of the rectangle? I get to say that the length is 35 inches and the width is 10 inches. And that finishes out my second problem. Moving on to problem number 3. All right, guys, last one. The type 3 is a quantity / price problem. You're going to see these a lot. It says your group purchased 25 tickets at this local movie theater. Each adult ticket costs $8 and each child ticket costs $5. Your group spent, I don't know why I lost that letter P there. Your group spent a total of $140. How many adult tickets were purchased? So the question's asking me how many adult tickets were purchased. I don't know how many were purchased. Please be careful because students will get this confused a lot, all right? Do I know how much each adult ticket costs? The answer is yes. So I'm not going to let A equal the price of an adult ticket because I know how much that is. It's $8, okay? What I don't know is how many of those tickets. So did I buy one adult ticket? Did I buy two adult tickets? That is how I'm going to define the variable, okay? So for this problem, I'm going to write let A represent the number of adult tickets. All right, so if I'm going to let A represent the number of adult tickets, because I don't know how many adult tickets were bought, what else don't I know? Well, they're starting to talk about child tickets, and I know that the child tickets cost $5, but I don't know how many child tickets were bought. So I'm going to say let C represent the number of child tickets that were bought. Okay, so I did step one. I defined my variable. Step two is the toughest part. That's where you come up with your own equations. So let's see. Are there any sentences that give me an equation? It says my group purchased 25 tickets. Does that mean they were all adult tickets? Nope. Were they all children tickets? Probably not. What I do know is some of them were adult tickets and some of them were children tickets, right? And together, it's going to be 25 tickets total. If I'm saying the word together, that means we're adding, and we're adding the adult tickets with the child tickets. So what do I write for adult tickets? We said A was the number of adult tickets together with the child tickets, and that's going to be 25 tickets total. The number of adult tickets plus the number of child tickets should be 25 tickets total. That's where that formula is coming from. All right, let's take a look at the second formula. The second formula says each adult ticket costs $8 and each child ticket costs $5. This is a little bit tricky because this is not enough information to come up with my formula. I do know that the group spent a total of $140. Okay, so we need to use all that information. And guys, we've done stuff like this before. For each adult ticket, it's $8. So if it's one adult ticket, it's 8. If it's two adult tickets, it's 8 plus 8, which is 16. If it's three adult tickets, it's 8 plus 8 plus 8, which is 24. That means for the adult tickets, we're counting by eights. And if we're counting by eights, then we should be writing something like 8 for each adult ticket, 8A. And I'm going to do the same thing for the child tickets, except for the child tickets, for one ticket, it's $5. For two tickets, it's 10. For three, it's 15. We're counting by fives on the child tickets. So together with the child tickets, which I'm going to be counting by fives for the child tickets, that should be, when I put the adult tickets, right, the money spent on the adult tickets plus the money spent with the child tickets, together, that should be a total of $140. Again, we've done these equations before, but it's been a while. It's been like 3 months since we did those word prompts. So hopefully this kind of kickstarts and reminds you like, yeah, I do remember something like that. Okay. And again, the more you see it, the more you're going to get exposed to it and the easier they become. But you do need practice on it. All right, so we did the difficult part, was set up the equation. Step 3, we're going to go ahead and solve the system either by using substitution or elimination. You notice that those variables are lined up and the equal sign is lined up. I got my A's with my A's, my C's with my C's, my numbers with my numbers, and then the equal signs match up. This is perfect for elimination method. So I asked myself, hey, right now, can I add up those equations? Nope, I cannot add those equations up because they're not going to cancel anything. So what should I do to cancel something? I should take, well, you got a couple of choices. You can either multiply the top by -8 or you can multiply the top by -5. Both are really good options. I'm going to go ahead and multiply the top by -5. I think that one's a little bit easier. So I'm going to go times -5, times -5, times -5. And let's see what my new equations end up looking like. On the top, -5 times I, that's -5. I'm sorry, -5 times A is -5A. And then -5 times C, that's a -5C, equals, and then 25 times -5, that's -125. On the bottom, what happens on the bottom? Absolutely nothing. We do not modify that bottom, so we're going to leave it as 8A plus 5C equals 140. Now that we have our system set up and it looks like the C's are going to cancel, I can go ahead and add these equations together. I'm doing this because I know those C's are gone, right? They're going to cancel each other out. So negative 5a plus 8a, that's going to give me 3a is equal to, and negative 125 plus 140, that's going to be a positive 15. We're going to go ahead and divide both sides by 3. I get a is equal to 5. I just found the first part of my answer. Let's go ahead and see if I need to find the second part. They said, how many adult tickets were purchased? Do I know that? Yeah, it was 5, right? So I don't need the second part. So I can go ahead and stop right here and just go ahead and do step number 4, which is to write down the answer and say 5 adult tickets were purchased. That takes care of the notes for today. Tomorrow, we're going to go ahead and finish up the rest of the notes, which is going to be the backside. But for right now, we're going to go ahead and stop right there. As always, if you have any questions, please feel free to ask.